location of the Texas slide. If you drove west of here like 3 hours, you'd see this limestone escarpment. And if you got out to the edge here and you got down on your belly and reached over the edge and kind of looked and did the fall to your death, you would see a fern growing in this crevice there. It's this guy, Myriopteris gracilis, known to many of you probably still as Calanthes fayei. It's a very easily recognizable fern. It's got these very hairy, thrice divided leaves, divided into these little bead-like segments. You can find this guy on a lot of different substrates, typically on limestone, such as the cross timbers or Chautauqua hills here in Kansas. Sometimes on some other calcareous substrates like dolomite here in southwestern Virginia. More rarely on gypsum, that's from Kansas there. And even occasionally on basalt, like here in the El Malpais Badlands in western New Mexico. And as the locations of these slides illustrate, this is also a very widespread species, found in 25, 27 U.S. states. It's into southern Canada and into northern Mexico. Much more widespread than almost all other species of Myriopteris. On the four corners here, there's 4 corners, there's some representative range maps of other Myriopteris species. Most of them tend to be quite regional, whereas gracilis is something that can be found from hot deserts, Mojave, Sonora deserts, up to places like Minnesota, British Columbia, Alberta, Wisconsin that have extreme cold winters, long cold winters, to humid, shaded deciduous forests in eastern North America, Virginia, Kentucky, and historically North Carolina. And all of this without sexuality. Gracilis is an asexual species, while these other 4 I'm picturing here are sexual. And this is a very common observation, and I think most people more or less run with the assumption that although asexuality might be a bad idea macroevolutionarily, over short terms it might convey some advantages. In this case, manifested as a larger range. We should be careful, though, in jumping to these conclusions. A couple reasons. Let's say we have an asexual range of an asexual species here in green and asexual in red. First thing is that there could be cryptic sexual populations all throughout the range of this asexual species, so in fact, it's not really exclusively asexual. If this is happening, if there's recurrent formation of an asexual species from sexual populations, the distribution of the constituent lineages of the asexual species could look like that. And so what we're doing is we're comparing the geographic success of the sexual lineage to the cumulative geographic success of a bunch of independent and genetically distinct asexual lineages. Right? Everyone with me? Yeah. So this was the logic behind my graduate student David Wickle's master's thesis. Let's ask these 2 questions in Myriopteris gracilis. Is it exclusively asexual? And is this big range one really successful asexual lineage or a bunch? First question was actually straightforward methodologically, but enormously time-consuming. All we had to do was count spores a bunch of times. So you guys know ferns. We're almost always looking at sporophytes. They make spores, which germinate into free-living gametophytes, which make gametes. Blah blah. Sporogenesis typically involves 4 mitotic divisions that precede meiosis. So right before meiosis, you got 16 spore mother cells. Each of them goes through meiosis. You end up with 64 spores in a sporangium. In asexual ferns, many of them do what we call dot-mantle sporogenesis, where what they typically do is they kind of monkey with that last mitotic division. And so instead of starting with 16 cells, they start with 8. Each of those, by the way, having twice the parental genomic complement. So 8 times 4 after meiosis gives you 32 spores instead of 64, half in a sporangium. Every once in a while, they will go ahead normally with that last pre-meiosis mitotic division, but meiosis is weird, and you end up with 64 spores that are really misshapen. Most of them just tiny little flecks of dust, clearly aborted. So we can take any specimen that's fertile, crack open a sporangium, look at it in glycerol, and see if we see either. So in a sexual, we would see 64 uniform, well-formed, happy spores. In an asexual, we would usually see 32 uniform, happy spores, and very rarely a bunch of little flecks of dust, up to 64. So we did that 606 times. We counted spores in these specimens all across the range, and we covered, basically the entire range. We even its range in northern Mexico is fairly uncertain, but we did count in Canada, northern Mexico, and all across the U.S., including these weird disjunct populations, and everything. We saw no evidence of sexuality anywhere across this range. So the answer to the first question is yes. Miriopterus gracilis appears to be exclusively asexual, so this large range has either been created or at minimum is being maintained without sex. Getting to the second question, obviously we needed some material, so did a lot of field work. David and I is collecting in New Mexico. A couple other spots. Between he and I and some collectors, we ended up with 120 specimens from 20 states. First collected a kind of a workhorse plastid locust. You can see the haplotype network there on the inset. Two very divergent haplotypes. There are 6 nucleotides. That's like 2.5 million years, I think, divergence after doing some basic dating. So that's a very deep divergence intra-specifically in this genus. You can also see they're very geographically non-random. One haplotype we basically find in the Missouri Ozarks, the driftless zone here, and the disjunct populations. The rest of it is the Arkansas Ozarks and the rest of the range with a couple exceptions. Once we knew about this, we went and looked at the material again, and these are morphologically distinguishable. The eastern material has significantly narrower pinnae, which collectively creates large gaps between subsequent pinna pairs, which gives the fronds leaves these overall more delicate open appearance. And if you look closely at the rachises of these are quite hairy and these are usually glabrous. So there's obviously at least 2 very different, deeply divergent lineages within Gracilis. So we can already more or less say yes to the second question, but we want to look more closely. So we got a genotyping by sequencing data set with fewer specimens, 73 in this case. This is a unrooted tree made from those data. We did parsimony and maximum likelihood. The colored nodes are the ones that received maximum support in both, with both approaches. The green lineage here is the one the blue one is the one we've already talked about. This corresponds to that eastern plastid group with a couple exceptions. So therefore these 5 colored clades are breaking up that large western group of material from the plastid data. So we can already see, even if we conservatively assume that all of this uncolored, all of these tips here, we just lump them in some kind of trash bag lineage, which is almost certainly not the case. But if we're conservative, there's at least 7 clear lineages within Miriopterus gracilis here. And if you just do some kind of ordination and stare at it, and you do some more sophisticated analyses, these, at least the ones we have a lot of individuals for, are quite obvious in multivariate space. This is the location of these, again, plastid for reference. In other words, we see this, again, some kind of eastern lineage, both from the plastid and nuclear genomes. And then these other colors here, this is breaking up that large western group. So the green and red lineages, they're somewhat widespread. And some of these other smaller lineages are more restricted. None of these lineages, though, approaches the total range of Gracilis just based on looking at a range map. So the answer to both these questions is yes. This large range is the result of, has either been built or is at minimum being maintained without sex, but it's the cumulative ranges of a bunch of genetically distinct, evolutionarily independent asexual lineages. So this cartoon that we drew earlier is probably a decent summary of at least what we know now about Miriopterus gracilis. And so when we are thinking about, when we look at a big range like that for an asexual species, and a much smaller one for a related sexual, we should be aware that we're likely comparing apples to oranges. We're unfairly comparing the cumulative range success, geographic success of a bunch of asexual lineages to a single sexual lineage. So we should keep that in mind. thanks to folks. So these are the 4 folks that, additional to our collecting, helped us grab material in the field. We had a lot of permit obtaining for this work, a lot of very generous folks at those agencies. And finally, and most importantly, these are the 17 collections at which we counted spores. And I know at least a couple of those curators are in here, including, where's my Colorado State curator? That was the very first place, the very first spore counting I did. So special thanks to you. But yeah, obviously, without the people that build and curate these collections, you know, you can't do that stuff. So, thank you.
We have several minutes for questions.
James, is there any evidence that those lineages of Gracilis don't have a common ancestor that's independent of all the other extant species?
So we have done, so its chloroplast sequences are I guess, distinct enough for me from the other sister species. In other words, we don't occasionally see plastid. In other words, those 2 plastid sequences aren't nested within sequences from other species. More importantly, I guess more convincingly, is Carl did a little bit of PAC biosequencing of at least one locus, so we can actually see, you know, nuclear sequences. We have both an eastern and a western individual in there, and those sequences form a clade. So we don't see sequences from other species that are obviously assignable to other species in Gracilis. It appears to be, by all measures, an autopolyploid. I should have mentioned that. It's a triploid. So this makes sense with recurrent formation. So it's almost assuredly an auto-triploid derivative of some now seemingly extinct sexual diploid ancestor, but one that was around long enough to fire off a bunch of lineages across what was maybe a large, even though maybe the sexual diploids range was large historically.
2 observations. We've looked pretty carefully at the disjunctions in the Driftless area. You have that population cluster. BI is the only disjunct from the south. All the other so-called disjuncts are from north. It represents our only disjunct from the south.
Well, it's worth noting that if anyone was looking carefully, the main biogeographic weirdo in this is there's a sample from Iowa County, Wisconsin, that has a nuclear genome, multi-locus stuff. It has a nuclear genome, a western nuclear genome, a western plastid genome, and is morphologically assignable to the western material. So this is just a direct plot of stuff. The blue stuff is the eastern material. The black or green stuff is the rest of the stuff. And that arrow points to the Iowa County thing. So there's a thing up there, the Driftless zone, that is western, it's assignable to all that western stuff. So whatever that means.
The second point that I would make is that in the Ozark region, that is also where we found sexual allelic glabella.
Yep.
So there could be in that old area possibly a sexual form hanging out.
I would love for someone to find a 64 spore Muriatrus gracilis. And in fact, I would richly reward any of you that could.